You're a developer. You care about privacy. You've got a Mac Studio with 64 gigabytes of RAM sitting on your desk, and you're wondering, do I really have to send all my code to Anthropic servers just to use Claude Code? What if you could run Claude Code against the local model, Qwen, DeepSeek, Llama, completely offline, no cloud or data leaving your machine? The short answer is yes, you can, but it's not a checkbox. It's not built into the UI, and there are real limitations that nobody talks about honestly. In this video, I'm going to show you exactly how it works, what breaks, what performs well, and whether the setup is actually worth it for serious Android development. No marketing, no hype, just a real picture. First, let's be clear about what Claude Code is by default. When you install it and run it, it connects exclusively to Anthropic servers. Opus, Sonnet, Haiku. Those are your options out of the box. There is no select local model dropdown. There is no built-in Ollama integration. There is no offline mode. This is not a criticism. It's just a fact you need to understand before we start hacking around it. Claude Code was built as a product, not as a framework. Its defaults are optimized for the best results with the best model Anthropic has, which is Claude. So when people ask, can I use local models with Claude Code? The answer starts with not natively, but the architecture makes it possible, because Claude Code communicates through an API endpoint that you control. Here's the key insight that makes this whole thing work. Claude Code doesn't care what's on the other end of its API connection, as long as the response looks like it came from an Anthropic model. Ollama, LM Studio, and other local inference servers have added compatibility layers that mimic the Anthropic API format. They accept the same request structure, return the same response structure. As far as Claude Code is concerned, it sent a request to Anthropic and got a valid reply. The mechanism is one environment variable. Anthropic base default, it points to Anthropic servers. You change it to point to your local Ollama server running on localhost port 11434, and now every request Claude Code makes goes to your machine instead. That's it, one variable. The rest of the tooling stays exactly the same. The cleanest local setup uses Ollama. It's a one-command install, it runs as a background service, and it exposes an API that Claude Code can talk to. Here's the full setup on Mac. First, install Ollama with Homebrew. Then pull the model you want. For Android development, I recommend Qwen 3-coder 14 billion or DeepSeek at 14 billion parameters. Then start the Ollama server, and finally set the environment variable to redirect Claude Code to your local endpoint. From that point on, you launch Claude Code normally. It looks the same. The slash commands work, the file editing works, the terminal tool works. The difference is that all inference happens on your CPU and GPU on your machine with no network traffic to Anthropic. The latency will be higher than Claude, typically 2 to 6 seconds per response on a Mac Studio, but for many workflows that's completely acceptable. Llama isn't your only option. LM Studio is a GUI-based alternative that's easier to set up for non-terminal users. It runs a local server on a different port and supports the same API redirect trick with Anthropic MyC URL. vLLM is the option for higher performance. It uses more aggressive GPU optimization and is better suited if you're running multiple concurrent sessions or need faster token generation. It requires more setup but delivers better throughput. Docker-based runners like Qwen or Local AI give you containerized model serving, which is cleaner if you want to version control your model configuration or run on a shared machine. For most Mac developers, Ollama is the right choice. It handles model management, updates, and API serving automatically. The others add complexity. That's only worth it if you have specific requirements Ollama doesn't meet. Let's be honest about what actually works well in this local setup, because there are genuine wins here. Code generation for well-defined tasks works fine. If you ask Claude Code to add a new function to an existing file, refactor a method, write a unit test, or generate a data class, local models perform these tasks adequately. The quality gap versus Claude Code is noticeable but not disqualifying. File navigation and codebase exploration work well too. Claude Code's ability to read multiple files, understand project structure, and search for patterns is largely independent of model quality. It's the tooling that matters, and the tooling is the same. Privacy is the strongest argument for this setup. Your code never leaves your machine. For proprietary code bases, enterprise projects, or anything covered by an NDA, local inference eliminates an entire category of risk that cloud usage introduces. Now, the honest part. Here's what breaks or degrades significantly when you switch to local models. Tool calling reliability drops. Claude Code relies heavily on the model's ability to correctly format tool use requests. Read this file, run this command, edit this line. Claude handles this almost perfectly. Local models, especially smaller ones, sometimes generate malformed tool calls, miss required fields, or call the wrong tool for the task. This causes the agent to stall or loop. Complex multi-step reasoning suffers. Tasks that require Claude to plan across many files, reason about architecture, or handle ambiguous requirements. These degrade noticeably. Local models are worse at maintaining coherent plans across a long conversation. Android-specific quality drops for the same reasons we discussed in the last video: lifecycle handling, coroutine scopes, compose patterns. Local models are less reliable on these compared to full-size cloud models. The gap is real. Know it going in. Let's get specific about your hardware. A Mac Studio with 64 GB of unified memory is a genuinely capable machine for local inference. Unified memory means the GPU and CPU share the same pool. Models don't have a hard VRAM limit like discrete GPU setups do. Practically, you can run 7 to 14 billion parameter models at full quality with fast response times. You can run 20 to 30 billion parameter quantized models at acceptable speed. You can run 70 billion parameter models in 4-bit quantization, but responses will be slow enough to disrupt your workflow. The full flagship models, DeepSeek 3 2.4 billion, cannot run locally on any consumer hardware. You access those through cloud APIs. For Claude Code workflow specifically, I recommend staying at 14 billion parameters. That's the sweet spot where tool calling is reliable enough and response time is fast enough to be useful. Given the 14 billion parameter target, which models should you actually use? Qwen 3-coder 14 billion is my top recommendation. It has the best tool calling reliability of any model in this size range, and its coding quality for Kotlin and Android is ahead of the alternatives. It also handles long context well, which matters when Claude Code is reading multiple files. DeepSeek R1 Distill at 14 billion is a strong alternative, particularly for tasks that require reasoning. The Distill version captures a lot of the capability of the full model. Its tool calling is slightly less reliable than Qwen, but its reasoning quality is competitive. Llama 4 Scout at 17 billion parameters is the most stable option if reliability matters more than raw quality. Meta has put significant work into the instruction following and tool use format, and it shows. Avoid anything below 7 billion for Claude Code agent workflows. The tool calling just isn't reliable enough. One limitation that catches people by surprise: this local model trick only works with Claude Code CLI. The web version at claude.ie and the desktop app do not support Anthropic Zerge Rubber redirection. They always connect to Anthropic's servers, full stop. The CLI is the only interface that respects the environment variable. So your workflow is terminal, export the variable, launch Claude, work in the terminal. No GUI, no sidebar in your IDE. There is an exception. The VS Code and JetBrains extensions that connect to the Claude Code CLI do work, because they're just front ends to the CLI process. If you're using one of those extensions, set the environment variable in your shell profile and it will apply automatically when the extension launches the CLI. But if you were hoping to use the web interface with a local model, that's not currently possible. The setup that actually works in practice for serious development is the same hybrid approach we talked about in the last video, but now you understand why at a deeper level. Local model handles the low-stakes work, completing a function, generating boilerplate, answering a quick question about syntax. The model quality is good enough, the privacy is absolute, and the response time is fine for these tasks. Cloud model, either through Claude Code's default Anthropic connection or through the DeepSeek or Qwen cloud APIs, handles everything that requires real reasoning, debugging a production crash, designing a new feature, reviewing a complex pull request. Switching between them in Claude Code means changing one environment variable. You can alias it in your shell, one command to go local, one command to go cloud. Two aliases, two modes, zero friction. That's the setup most productive developers end up at. Here's the honest summary. Yes, you can use local models with Claude Code. The mechanism works, the setup takes about 10 minutes, and the privacy benefit is real. But it only works in the CLI. It requires Ollama or a compatible local server. It works best with 14 billion parameter models, and the quality gap versus Claude Code is noticeable for complex tasks. For your Mac Studio with 64 GB of RAM, Qwen 3-coder 14 billion is your best local option. Set Anthropic Zes's URL to localhost, run Ollama in the background, and you have a fully private coding assistant that handles most day-to-day tasks well. For anything complex architecture, debugging, multi-file refactors, switch to cloud, one alias, 1 second. The local versus cloud question isn't binary. The right answer is use both for the right tasks. Subscribe for more practical AI development setups.